Sodium and chlorine are both elements. When sodium is heated and placed in a jar of chlorine, it burns with a bright flame, and the result is a white solid that has to be scraped from the sides of the jar. It looks completely different from the sodium and chlorine. So a chemical reaction has taken place, and this white solid is sodium chloride. Atoms of sodium and chlorine have bonded together to form a compound. But why do these atoms form bonds? Well, we can get a clue by looking at the elements of group 8, the noble gases. Now, their atoms do not form bonds, and it's because the atoms seem to have a very stable arrangement of electrons in the outer shell. This makes the noble gases unreactive, and that gives us the answer to our question. Atoms bond with each other in order to gain a stable arrangement of outer shell electrons, like the atoms in group 8. In other words, they bond in order to gain 8 electrons in the outer shell, or 2 electrons if they only have one shell. So, let's see how these ideas apply to the reaction that we saw just now. Sodium plus chlorine reacting to form sodium chloride. And buckle in, because there are quite a few ideas that you're going to be introduced to in the next slide. Sodium atoms have just 1 electron in their outer shell, so to obtain a stable outer shell of 8 electrons, they lose that electron to another atom. They become what's known as a sodium ion. The sodium ion has 11 protons but only 10 electrons, so it has a charge of 1+. As you can see, the symbol for sodium is Na, so the symbol for the sodium ion is given Na+. The plus on the top right hand side means 1 positive charge. Na+ is a positive ion. Now, chlorine atoms have 7 electrons in their outer shells. Then it can reach 8 electrons by accepting 1 electron from another atom, and it becomes a chloride ion. The chloride ion has 17 protons only. It has 18 electrons, so it has a charge of 1-, as you can see. The chloride ion has a charge of 1-, so we call it a negative ion. Its symbol is Cl- with the minus on the top right hand side of Cl. So, just a quick recap. Remember, you can get the number of protons inside an atom from the periodic table. In an atom, the number of protons is equal to the number of electrons. But if you're changing the number of electrons in the atom, you cannot call it an atom anymore. It becomes a charged particle, and we call that an ion. An ion is a charged particle. It is charged because it has an unequal number of protons and electrons. So, to obtain stable outer shells of 8 electrons, a sodium atom must lose 1 electron and a chlorine atom must gain 1. When a sodium atom and a chlorine atom react together, the sodium atom loses its electron to the chlorine atom, and 2 oppositely charged ions are formed. Here, sodium electrons are shown as dots and chlorine electrons are shown as crosses. These 2 ions have opposite charges, so they attract each other. The force of attraction between them is strong and is called an ionic bond. An ionic bond is the bond that forms between ions of opposite charge. And what's really important to realize is that if you pick any ion of a specific charge, it's not just attracted to only one other ion of an opposite charge, but whatever is surrounding it that is of an opposite charge. So these ionic bonds just build up and give your structure huge amounts of strength. Now, when sodium reacts with chlorine, billions of sodium and chloride ions form, but they do not stay in pairs. They form a regular pattern, it's called a lattice, of alternating positive and negative ions as shown. The ions are held together by these strong ionic bonds. The lattice grows to form giant 3D structure. It's called giant because it contains a very large number of ions. This giant structure is the compound sodium chloride, what we normally call common salt. It's important to note that the charges in the structure in sodium chloride add up to 0. The charge on each sodium ion is 1+, and the charge on each chloride ion is 1+, so overall, the compound has no overall charge. Now, other metals and non-metals follow the same pattern. A metal reacts with a non-metal to form an ionic compound. The metal atoms lose electrons, and the non-metal atoms gain them. The ions form a lattice, and the compound has no overall charge. Magnesium is a metal, and oxygen, which is a component of air, is a non-metal. They react together to form an ionic compound in a way that I hope is very familiar to you. A magnesium atom has 2 outer electrons and an oxygen atom has 6. So when magnesium burns in oxygen, each magnesium atom loses its 2 outer electrons to an oxygen atom. Magnesium and oxide ions are formed. These ions attract each other because of their opposite charges. Like the sodium and chloride ions, they group together to form a lattice. The resulting compound is called magnesium oxide. One magnesium ion for each oxide ion, so its formula is MgO. Now, the magnesium ions and the oxide ions all form a massive giant lattice structure with billions of oppositely charged ions all linked together through ionic bonding. For each magnesium ion, there is one oxide ion, so the charges balance out and the total charge is 0. The magnesium ions have a 2+ charge and oxide ions have a 2- charge. So what happens when you have 2 electrons on the outer shell of a metal atom, but only 1 space in the outer shell of a non-metal atom? This is what happens when magnesium chloride burns in chlorine. Each magnesium atom reacts with 2 chlorine atoms to form magnesium chloride. Now, each of the ions, when that happens, has 8 outer electrons. And the ions form a lattice with 2 chloride ions for each magnesium ion. The formula is MgCl2, which has no overall charge. Now, before you progress on to the last part of this video, make sure that you can answer with confidence these 4 questions. Why not have a look at the comment section, and if you have answers, put them in the comment section for other people to review at a later date. Not every element forms ions during reactions. In fact, out of the first 20 elements in the periodic table, only these 12 easily form ions. Note that hydrogen and the metals lose electrons and form positive ions. The ions have the same name as the atoms. Non-metals form negative electrons with the names ending with IDE. The elements in group 4 and 5 do not usually form ions because their atoms would have to gain or lose several electrons, and that takes too much energy. So to name an ionic compound, all you need to do is just put the names of the ions together with the name of the positive ion first. Here are 2 examples: potassium fluoride and calcium sulfide. Now there are 4 steps that you need to follow to work out the formula of ionic compounds. And we've got a couple of examples, so don't worry, just take yourself through the examples and in next to no time you'll be able to do this yourself. First of all, write down the name of the ionic compound. So here we have lithium fluoride. Write the symbols of these ions. So we've got Li+ and F-. Now there must be no overall charge, so balance the ions until the positive and negative charges add up to 0, and then write the formula without the charges. Now the previous example is pretty straightforward because the Li ion is a positive charge and F is a minus, so they kind of balance each other out. You only need one of each, so the formula was LiF. What happens when the charges are different? So let's take the example of sodium sulfide. Sodium has a plus charge and sulfide has a 2- charge. Now 2 sodium ions are needed for every sulfide ion to make the total charge 0. So the formula is Na2S. At some stage during Gcse, you'll come across a block of elements called the transition elements. These include many common metals such as iron and copper. Now, some transition elements form only one type of ion, but most transition elements can form more than one type of ion. So how do we indicate that in the name? Well, look at the 2 examples that you have on the screen. Copper 2 oxide at the top indicates that you actually have copper ions with a charge of 2+. Copper 1 oxide contains copper ions with a 1+ charge. Okay, big leap towards an A star for this slide. All the ions you've met so far have been formed from single atoms, but ions can also be formed from a group of bonded atoms, and these are called compound ions. And the slide shows the most common ones. Remember, each is just one single ion, even though it contains more than one atom. The formula for their compounds can be worked out using the rules that we've covered in the previous slides. Big deep breath for working out these formulas. Sodium carbonate first. Now the compound ion is carbonate and it's got a 2- charge. So because the sodium ion has a 1+ charge, you need 2 to balance each of the carbonate ions. So the formula is Na2CO3. Write the 2 after the Na. Calcium nitrate. You actually need to double the number of nitrates because the calcium ion has a 2+ charge. Use brackets, put them around the nitrate, and then put a 2 after the bracket. Now it's your turn. Have a go at these questions and leave your answers in the comment section below. Then compare your answers with those that have been written by people who have previously watched the video. I hope that you found this video really helpful. If you have, please leave a like and support the channel by hitting the subscribe button. best of luck with your GCSE exams. Take care. Bye.